Hello, my name is Robert Magee, and today I'm here to talk to you about a procedural primer for artists. As games get bigger with vast worlds that need to be populated with lots of content, procedural techniques are critical. Houdini and its node-based workflow provides a strong pipeline solution to meet this growing need within the game dev community. As a game artist, your main goal is to build a compelling experience for your audience. To achieve this, you need to be able to art direct all aspects of your game while generating playable art that is optimized for your engine. Some of the challenges you face are repetitive tasks that consume too much time and larger worlds that can be overwhelming for teams. Last-minute changes needed to improve the game can also be costly in both time and resources. Today we're going to discuss how a procedural solution can help you meet these goals and challenges head-on. Let's start by taking a look at what we mean by procedural, especially when it comes to working in Houdini. Everything you create in Houdini gets stored in nodes with parameters capturing your creative decisions. These nodes are wired together into networks that define a non-destructive flow of data. Making changes on any node will cascade down to create an updated result. Networks can then be packaged up into digital assets and can be shared with artist-friendly controls. This lets you feed a larger pipeline with artist-driven tools. Let's start by exploring how to create cables using Houdini's node-based workflow. So here we start with a line, and you see it's represented by a node in the network. We then resample that with a second node that gives us a lot of extra points, and we control how many points using that node. We're then going to sweep that, not to create a shape, but rather to create a collection of cables, all centered around this shape. We're going to add some attribute noise to offset these a little bit. To create a more organic look to your work, Houdini has lots of great tools for changing the way things look in a natural way. Now, once we have that, we're going to set up some nodes that we're going to analyze the relationship between the different points, basically their rest lengths. And those relationships will then be used to determine the p-scale of the cable itself, so how much the radius will be scaled up. So as you can see, as we add more of these pipes, automatically they're going to be changed. The radiuses are going to change depending on their interrelationship. So those are nice kinds of things to have built into a system because you'll get a good look automatically when you deploy the tool. So the next thing is to do vellum, which is a simulation. We want to drape the cables. And so one way of doing that is to do a vellum simulation. First we have to find the anchor points at the beginning and end of each of these lines. And those are going to be put into a group, and that group will then be used to pin those down. And then when we drape it, we got the cables. Now we're going to use a for each loop jumping ahead to wrap some other secondary cables around the primary cables. And by doing this, we'll create even more visual interest in the system. And once we have that, we merge that back into the system we had before so that we can run the simulation, make some groups for primary and secondary cables. That'll help with things later. And when we simulate that, you see we get a much more interesting organic result that's going to be visually pleasing in the game. And yeah, so that's all the parameters are represented here in these nodes, and you can run through the whole system to create an updated result. Now we're going to talk about artist-built tools. Since you have the network, you're going to wrap it up into one of these tools. But first, let's ask the question, why go procedural? For artists, a procedural workflow provides creative control, making it easier to iterate. Procedural solutions can be scaled. A solution that works for one building can be scaled up to meet the needs of a whole city block. And assets can remain live deep into production. Changes can be made confidently right in your game editor. From a pipeline point of view, an asset can create game-ready art automatically. Collision geometry, level of detail, UVs. All of these things can be set up properly by the tool. The artist doesn't have to worry. And this means that smaller teams can accomplish more because the tool streamlines the workflow. Taking the network of nodes created in Houdini, they can be encapsulated into a single node, a Houdini digital asset or HDA file. This is a file on disk that can also include embedded geometry, textures, handles, and more. You can then promote parameters to get a high-level interface. This new tool can then be used back in Houdini, where it acts just like any other node, with the interface that you built earlier making it easier for artists to work with this high-level tool. Let's package up the cable tool to create a Houdini digital asset. So we select the nodes, collapse it into a subnet. Then once we have that, we're going to create a new digital asset, give it a name, location on disk, and there we go. Now right now it doesn't have an interface, but we're going to build one. First we put an output node to make sure that the output of the network is always working properly. Then we're going to put some inputs and outputs. And the outputs, what we're going to do is we're going to take the line out, and we're going to put the second one in as collision geometry for the simulation. So if we put a box, a line in here, we can see how these feed into the system. So sometimes you, rather than have nodes inside, you want to have them outside because they'll be represented, they'll be what you're plugging into in your scene. So you don't want to have them in the system itself. Now we're going to build the parameter interface. You can see we just add folders and then drag and drop parameters. So you're dragging and dropping parameters from down below up above, and that creates this interface. So you have your resolution, amount, what you can do with a small cable, and then your simulation tab for working with that. So this is the node you'll give out to artists, and they'll be able to accomplish what they need without worrying about all the nodes that are inside. And they'll get their results quickly using this tool. Now let's talk about HDAs working inside of a game editor such as Unreal or Unity. But first, how would you get to this point? At first, artists request a new tool needed to complete a task, like this tree. Tech artists then define the workflow and build an artist-friendly UI. The tool is published as a Houdini digital asset, then deployed to the game editor. Level artists use the asset in the game editor, which allows them to work in a preferred environment. It's easier to set up and design something like this tree in its proper context. How does this work? Well, here we have the digital asset collapsed into a single node. Instead of using this in Houdini, we want to use it in a game editor such as Unreal or Unity. This requires the use of the Houdini Engine plugin. With the plugin, assets can be loaded into the editor, and under the hood, Houdini cooks the nodes and delivers the results back to the host application. The high-level interface built earlier is available to the host application, and any parameter changes again work under the hood to cook the nodes. This allows artists to use the tool in the editor, which they are familiar with, while procedural solutions work behind the scenes to deliver game art. Let's take a look at the cable tool in Unreal. So we've brought it in. Now it's not working yet because we haven't plugged a curve in yet. So we do that as an input, and we can use the default curve input that Unreal has. And you just press the Alt key on the endpoints to add new ones. So we can add 2 endpoints there. We've got sort of a nice curve here. And if we simulate that, you'll see it goes right through the ground. And that's because we haven't added the ground surface and the elements, the props, as collision geometry. So once we do that, we're in better shape, although we're getting this weird bulging in some of the cables. So one of the things we're going to do here is we're going to open up what's called Session Sync. And this is where you take everything that you're doing in Houdini and in Unreal and parallelize it into Houdini. And now you can go back and debug and see, why is this happening? So we go in here and we start to take a look at this, and you can go through the network, and what we find is this really seems to be tied to the radius. So you see at these corner points here, the radius gets really big, and that's because the distance between those areas is not even, and therefore we're not getting the result that we want. So one of the ways to deal with this is to say smooth out that curve as a subdivision, and then the points will be more evenly spread and we won't get those bulges in the p-scale. So it's nice to be able to debug these kinds of things here in Houdini and send the asset back to be used again. So once we have that ready, we'll save it. And when you save something on disk, then in Unreal, it can pick up that asset and the updates are all ready to go. Just have to re-cook the node. And there we go. So now we've got the asset working in Unreal. Now, to see the same tool in a more real-life context, here's a cable tool being used inside a level. So as the level's being designed and organized, this cable tool can be set up in context to interact and connect with other parts of the scene. So this is an ideal way to work because the artist is able to work in context using the software they know, and Houdini is just behind the scenes doing its job. So let's take a look at the design process for assets. Environment artists and level designers identify repetitive tasks that could use high-level tools. They then work with tech artists to streamline those tasks using procedural assets. An artist could prototype the solution in Houdini, then a tech artist generalizes it and builds its UI. It's important to work with tech artists to define what kind of UX is needed for the tool. To create the asset, the tech artist builds a plan based on input. It is important to define what the asset will output and how it fits into the game pipeline. Does it meet a specific or general need? Is it for a single type of building, or is it for any building type? Be sure to set up a feedback loop or testing phase to catch any issues with the tool. Earlier we saw this using Session Sync to debug the cable tool. As the tool is refined and updated, be sure to have a plan to deploy the changes. Houdini already does this when assets are updated, but you may want to have more control over this process. So here's some other tools. This is a fence tool that uses a curve input. And again, you see this kind of tool being used in context. And just by adding extra points to this curve, we can bring the rail up, down. And what's neat here is, this rail will have its collision geometry set up, so people will walk up against it and everything will be safe. Any textures, UVs, all set up, or you've even got to see it sort of has the lighting on the rail. So very interesting packaging up of this tool. This is a stacking tool. This tool allows you to set up an area, let's say with this box. And what you want to do is within that area, put a bunch of stacked objects. So instead of placing all those things by hand, you go in and you say, get me a few props. And we'll take maybe like three few static meshes, bring that in. And once you've got that set up, you plug that in. And now you can look at it and say, okay, there we go. We've stacked up some things. If we want to make it bigger, we can update that and it'll recook. Make that a little bit off like this, it'll recook. So again, work that you would normally have to do by hand, it's all being taken care of here, including the stacking of the objects and some of them sort of falling off to the side a little bit. All that's packaged up nicely here. You can actually get a tutorial for this one on the SideFX website. Okay, so here we have a building tool. As you can see, again, you've got big blocked out shapes used as the main input. And once those are set up, then you can set up what the building will look like. So there's built into this certain details, windows, air conditioners, railings, entrances, and so on. And all of that is built into the tool. So the game artist can just put it down, block it out, and get a result. And then they've got parameters to change the details. So if they want, well, first they can reblock it a little bit if they want to here, and then they can go through and say, well, I want building window type A or window type B. You can also go in and add other details. Here's a stair asset that can be put in front. Probably need to move some of those props, but once we have this set up, and this can have a whole bunch of different configurations, looks, feels, railings, not railings, can bend it. So the asset has a lot of the kind of things that you need when you're putting this detail into your level. So that's important. Here we have some scaffolding. Again, lots of detail in this, but because a lot of it is sort of repetitive, it's been able to set up with instancing, and there's a system which will allow it to be configured either by hand, by directly adding these together, or by again taking a shape and saying place yourself within this shape, and then go to whatever height is appropriate based on that shape. And yeah, and we want to make that a little longer, just make that box longer, update that. So this is a very nice way of working. You're able to quickly evaluate it within context. Is this what I want? Imagine if you'd gone back to a modeler and said, okay, build me a scaffolding. You bring it in, it doesn't work, you got to go back to the modeler. That's not necessary with these procedural assets. You're working right in context and making those decisions right then and there. Here are some assets for doing signage. So in Houdini, these assets actually allow you to configure some signs, have different videos, have different logos, and you can mix and match these using the procedural solutions in Houdini. And then when you bring that into Unreal, again, you just pick and say, what do you want each sign to be? How do you want it to work? And that's all based on a procedural system. And you can put these on actual signage pieces of geometry that also are procedural. So you can figure out the configuration, the size, the shape, where do you want to put it. Then you can take it and what's it like on the front, what's it like on the back. And we want some detail there, make it a little cool. And all of this is configured to be optimized for gameplay. Now, of course, this is Unreal Engine 5, so Nanite is a part of this story, so optimization is a little different in that world. But it certainly is part of the story, is how do you make this work best for your particular game engine? And assets would be designed accordingly. And here we see an Ivy tool that we sort of saw a picture of before. So in this case, you're just taking another piece of geometry and wrapping it with the Ivy. Of course, this uses a lot of instancing to be as efficient as possible, and it's can be configured in a number of different ways. Do you want the hanging vines? Do you want them to fall to the ground? This is where you again bring some simulation in, like we did with the cable, and maybe actually say, let's make these things fall to the ground. Let's make tons of them, and then have some of them fall to the ground. So you can have a lot of fun building this up to the look that you want or you need for any particular situation. Of course, because this tool is generic, we can attach Ivy to other things in other places within the same level or in other levels within the game. So really exciting opportunities with these procedural assets. Now, one of the things that is important for artists is the efficiency of the tools. They need to be snappy to work with in order to support the creative process. Let's talk about some of the techniques that can be used to optimize procedural solutions in Houdini. The first is compile blocks. These are special nodes that bookend your network. With these in place, many nodes can be processed like a single node, which is faster to initialize. These are multi-threaded for each loop that can be spread over multiple cores. While not all nodes in Houdini can fit inside a compile block, they are worth exploring because they create faster UX for your artists. Another technology in Houdini is PDG, or the Procedural Dependency Graph, where you set up task operators. These nodes allow you to automate a wide range of tasks, and not just Houdini tasks, Python tasks, render tasks, and more. Each task is assigned to a processor, and the task graph lets you monitor its progress. Tasks can be deployed to a compute farm or the cloud using a special scheduler such as Deadline. By processing tasks this way, you can speed up more complex solutions, and artists can see results more quickly. The way PDG networks work is that you start with a node that then gets assigned a collection of tasks. A scheduler is then used to assign the task to either a single computer or compute farm. Here, this local scheduler assigns tasks to 3 cores. In the HUD, you can see 7 tasks completed, 3 in process, and 70 in the queue. If we assign the task to 11 cores, then the processing will happen faster. And if we use a different scheduler, such as Deadline, we can assign the task to many more cores for even faster results. Here, a compute farm or even the cloud can be used to complete the tasks. What is exciting is that you can also add PDG or top networks inside your digital assets. This means that they can be working under the hood while you use an asset in a host application such as Unity or Unreal. Here's a city building example set up in Unity. So we load a city asset, and this asset needs to be cooked. So you go to up on the Houdini engine, you say PDG, create asset link, and then from here we can cook that. So the network with the scheduler that's designed to go either to a single computer or off to a farm, you're going to cook that, and then the results are going to start appearing here in the game editor. So you can see it saying how many are being cooked, how many are finished being cooked, how many are cooking, and there we get a city built up using that process. Now, this particular city is based off of an image for a sort of a city street map. So we're going to replace that with another one. And in doing that, we'll see it update. So it gets recooked when it sees that something's changed, because the topnet's able to recognize when some aspect of the network has changed, and then goes and dirties the nodes and recooks them. So there we get a new one fairly quickly. And again, this could be going off to a farm. If it was these were more complex buildings, it would go off to a farm and give results. And just changing the position of where the city center is, that also creates a cook there. So having PDG inside your assets can be a very, very good way of giving faster feedback for artists working with digital assets. Now let's take a look at some projects that use Houdini to create game art. These production stories are all available on the SideFX website under Community, Customer Stories, or under Learn, Talks, and Webinars. For Far Cry 5, Ubisoft used Houdini digital assets as part of their world creation toolset. Houdini Engine worked under the hood for tools that artists could access interactively. Assets were built to create things like water, cliffs, biomes, as well as fences, power lines, and roads. For Spider-Man, Insomniac Games created an open world using the tile regions that were expressed as tasks for PDG. Point clouds are generated for instancing of geometry assets. Tools were also created for procedurally placing snow mounds, holiday decorations, and even navigation clues for Spider-Man to move around the city. The Ascent by Neon Giant used a wide range of digital asset tools for creating cables, pipes, decals, rooms, and more. Magnus Larsson has detailed videos on his ArtStation page that will show how these tools work in action. For Crash Bandicoot, King used procedurally generated hexagons as a base, then created a tile system within a tile system to populate the world. The key was to automate the boring stuff while giving artists the ability to art direct the results as needed. In Nanotale Typing Chronicles by Fishing Cactus, Houdini assets were used to block out and add set decoration. Curves were used to control the placement. The team built their own library of tools and also used Houdini for animation and rigging. If you'd like to go procedural for your projects, the next question is, how would you learn to do this yourself? On our website, SideFX has a wide range of learning tools, including starter kit assets, quick start tutorials, and lessons covering world building, level design, and PDG. Be sure to go to sidefx.com/learn to access these materials. You can also check out Project Titan, which was used as the artwork for this presentation. This is an in-house tech demo that was designed to help test integration with Unreal Engine 5. It was created with a small team working part-time, and there are tutorials and a dev blog to teach you how this project was created. The cable tool we discuss in this presentation has a full tutorial that covers every aspect of the process. Coming soon will be a demo scene that you can download and explore. Go to sidefx.com/titan to follow as this project progresses. Thank you for joining me today, and I hope you have a greater appreciation for how procedural techniques can enhance your game development pipelines, especially for artists who need to make creative decisions on a day-to-day basis.